Think back to what using the internet used to feel like. You'd click a link, the screen would flash white, and you'd sit there staring at a blank page, waiting for the whole thing to painfully reload. Today, using a modern web application feels entirely different. Navigation is instantaneous. You click a button, a new screen slides in, and the page itself never actually blinks. This smooth, uninterrupted experience is powered by something called a single page application. As the name suggests, your browser only ever loads one single web page, and everything else happens seamlessly inside of it. Now, let's look at the front end and understand how this React app is structured. In this project, the front end handles the login, routing, chat screens, and general user experience, while the back end handles the heavy data processing and database management behind the scenes. The front end focuses on orchestrating this wait-free experience, instantly translating your clicks into immediate actions. Every React app starts with a foundational HTML shell. This base file is where the application mounts. It doesn't contain much business logic, but it provides the essential root container where the interface renders. Next, the main entry file goes to work. This file is responsible for taking our React application and mounting it directly inside that empty root container, officially kickstarting the program. But immediately, we run into a structural problem. Let's say a user logs in on the main screen. How does a deeply buried chat screen component know that this specific user is securely logged in, without constantly asking them to re-verify their identity? The solution is a context provider. When a user is verified, it instantly broadcasts the authentication state. By wrapping this around the component tree, shared data becomes universally available to every individual file. Managing state globally eliminates the need to manually pass authentication tokens down through every single structural layer, ensuring the app responds instantly to the user's identity. Now that the application knows who this user is, we need to handle navigation. The main application component sets up route definitions, dictating how users smoothly transition from screen to screen. It manages this movement using a mechanism called Clientside Routing. This controls all user navigation entirely within the browser, without ever contacting the distant server to ask for a new web page. Client-side routing dynamically shifts the interface modules directly in front of the user, without reloading the page. The system gracefully moves them between the login screen, an FAQ page, their home dashboard, and live chat sessions. Handling all of this routing logic entirely inside the browser is the single biggest factor in giving a website that lightning-fast native app feel. Of course, eventually, the front end does have to communicate with the back-end server. When a user submits a chat message, that input needs to be sent off for processing. If every individual screen in our app tried to write its own instructions for how to talk to the server, we'd have chaos. It would be chaotic if every component wrote its own uncoordinated networking code to fetch data. To fix this, a custom request helper centralizes all API calls into one unified method. It features a public pathway and an authorized pathway. For authorized requests, it automatically attaches the JWT token from local storage to the data packet, proving it's legitimate before the server processes it. Abstracting this networking logic into a centralized helper reduces bugs and makes the code easier to maintain. The final touch on all of this is the global status sheet. This acts as the interior design, ensuring the app is visually consistent, clean, and professional across every single screen the user interacts with. Stepping back to look at the entire front-end architecture, a clear pattern emerges. The front end deliberately avoids heavy computation. Instead, its job is entirely organizational, providing a responsive interface, handling routing, and communicating seamlessly with the backend. By separating these responsibilities, the foundational shell, the context provider, the routing logic, and the central request helper, the application remains organized and efficient even as it grows more complex. Know that the front-end architecture is clear and organized. It's time to step over to the server side. In the next video, we'll see how the backend handles data, live chat sessions, and requests to the AI model.